Good afternoon, and thank you for joining us in this exciting discussion about some of the opportunities afforded by advances in neuroscience to the world of training and mission readiness. My name is Jonathan Drucker. I'm a neuroscientist at Aptima, and I'm joined by my colleagues Shannon Heald from the University of Chicago and George Kong from Reflexion Interactive Technologies. Today, we're going to talk about BOLT BCI, a neuroadaptive brain-computer interface learning platform. At its core, the purpose of BOLT BCI is to use advances in neuroscience to accelerate mission readiness. Training is costly and time limited. In the case of U.S. Army medical personnel, there can be as little as 5 days to administer the specific training needed to get them out into the field. And the stakes are high. In a potential mass casualty event facing the U.S. or our allies, fast, efficient, and effective training can be literally a matter of life and death. And too often, training is one size fits all. That means it's uniform across learners, where everyone receives the same training, and therefore it cannot account for differences in aptitude. Therefore, there is an urgent need for training that is efficient and effective, where time is of the essence, but we cannot cut corners. Tailored to the individual, not just their innate aptitudes, but also to their current cognitive and affective states. And based on neuroscientific advances. Neuroscience can provide additional insights into an individual's cognitive and affective state. We propose that we can leverage these insights, and that's the opportunity before us. We build on an alternative technical approach. Adaptive learning is the idea that content delivered to the learner can change in response to performance. Typically, these changes are based on behavioral performance, such as how someone did on the last question or trial. Neuroadaptive learning takes this a step further. Adaptive learning is supplemented with neuroscience, incorporating neurophysiological signals into an adaptive learning framework. Our solution is called BOLT BCI, which will be a turnkey hardware and software solution, ready to go out of the box. It consists of 3 components: an interactive training platform with neurophysiological measures and AI analytics. As a finished product, BOLT BCI will accelerate learning and enhance retention by adjusting itself in real time to each learner's cognitive and affective state. So BOLT BCI will provide 5 key mission benefits. First, increased mission readiness. That means rapid time to proficiency, increased throughput, and reduced costs by obviating the need for retraining. Second, enhanced performance. For example, in a similar task for training ophthalmological surgeons, researchers at the University of London observed a 6% improvement in microsurgery task performance accuracy and a 26% increase in efficiency. I'll present some data later. Third, empirically validated methods. We're not starting from scratch here. We're building on a solid foundation of existing technology. Fourth, low programmatic risk. The neurophysiological technology and methods underlying BOLT BCI are already at TRL9 and have been rigorously validated. Reflection's interactive learning environment has been successfully commercialized and is already in use in labs, athletic programs, and rehab facilities throughout the country. The innovative component that we will spend the next year developing will be novel analytics and the synthesis of mature technologies to create an innovative solution that is greater than the sum of its parts. And finally, a clear path to commercialization. Reflection is fully productized and is poised for growth. Aptima has a decades-long history of transitioning new technologies to DoD programs of record. Our subsidiary, Aptima Ventures, is our conduit for creating new ventures to commercialize products in the private sector with VC backing. A good brain-computer interface, or BCI, puts the human in the loop. That means that not only is the trainee learning, but their neurophysiological state is fed back into the system, making learning more effective and efficient. This forms a closed loop, where training can be optimized iteratively and in real time. Let's take a look at the 3 components of our proposed system and see how each member of the team will contribute. First, Reflexion has developed and commercialized a cutting-edge interactive platform for rapid and effective learning. With the already existing Reflexion platform, trainees can build a foundational set of visuospatial and motor skills. Reflexion is best understood by seeing it in action.
We get these kids who come in with goals. Most of the young kids want to play in high school. The high school kids want to play in college. Reflexion makes our job easier because we no longer have to come up with any kind of drills to train the kids' neural response. We used to put different colored cones on the ground and yell a color and see if they react to that color. Now we can stick to what we do with the meat and potatoes of our training and allow the Reflexion to train their neural skills.
Next, Scientists at the University of Chicago have designed a measurement strategy to collect EEG, HRV, FNIRS, and other signals related to cognition and affect. Here's an example of real-time electroencephalography, or EEG. Electrical voltage potentials generated by neuronal activity are measured at the scalp, where their rhythms and amplitudes provide insights into cognitive and affective state. Finally, Aptima puts it all together. Aptima's artificial intelligence-based analytics will adapt to the individual learner's cognitive and affective state. Our most relevant prior work is an artificial neural network-based algorithm for estimating user workload. Called Fuse2 and trained on the NASA TLX workload instrument, this is one example of Aptima's AI analytics that will be leveraged for BOLT BCI. The output of these AI classifiers will then be fed back into the Reflexion system, adapting the training protocol to accelerate learning and enhance retention. Have a look at Aptima's approach to machine learning, AI, and data science in general.
The third wave of artificial intelligence, or AI, is revolutionizing the way we learn, train, and work. Aptima is leading the way. To deliver precision learning, Aptima makes sense of large data sets to understand organizational and mission needs, and assess the learner's current state, as well as measure how skills and knowledge evolve.
Let me introduce you to our team. Aptima is a human-centered engineering firm with more than 25 years' experience providing solutions to the Department of Defense and other government agencies. We have in-house expertise in multiple domains, including neuroscience, artificial intelligence, and adaptive learning. Our personnel have backgrounds in academia, industry, and military service. That's me, Jonathan Drucker, in the elaborate FNIRS headgear. My background is in neuroscience research and consulting, with expertise in methodologies such as fMRI, EEG, FNIRS, and RTMS. I'm joined by Dr. Tim Halverson, Senior Research Engineer in Aptima's Performance Assessment Technologies Division. Dr. Halverson is an expert in cognitive modeling and artificial intelligence. Reflexion Interactive Technologies has developed an interactive learning environment that's fun, engaging, and has been shown to produce measurable results in a variety of domains, with more than 50 installations nationwide of their innovative hardware and subscriptions for their cloud-based analytics. This is George Kong, Chief Technology Officer. Prior to joining Reflexion, Mr. Kong was a founding engineer at Liberate Technologies, where he was a key contributor to their IPO. He is joined by Dr. Dan Labey, an ophthalmologist and the scientific advisor to the Reflexion team. He has published over 35 peer-reviewed articles on vision science and sports, and has been the official team ophthalmologist for numerous professional sports teams like the Boston Red Sox and Houston Astros. Our colleagues at the University of Chicago represent two preeminent labs. Howard Nussbaum and Shannon Heald are with us from the Apex Lab. They are cognitive neuroscientists who have published more than 100 peer-reviewed papers on learning and memory, decision-making, perceptual attention, and communication. Dr. Nussbaum, director of the lab, is also a former division director at the National Science Foundation. Dr. Pedro Lopez is the director of the Human-Computer Integration Lab. Their wearable muscle stimulation devices enable users to manipulate novel tools and accelerate their reaction times. Dr. Lopez's work frequently captures the attention of media, such as the New York Times, MIT Technology Review, and Wired. He has some really cool videos of what they've accomplished with haptics and muscle stimulation. I don't have time in this presentation, but I encourage you to check it out online. Having a great idea is only half the battle. You then need a way to get it out into the world, and that means having a great reputation in an extensive network in multiple sectors. With deep ties to the DoD, private industry, and academia, this team is uniquely poised for human subjects research, hardware and software development, and synthesis of a groundbreaking, commercially viable product. Aptima itself has a 25-year history providing human-centered engineering solutions to the government, typically in the Department of Defense, including DARPA, Special Ops, DHA, and so on. For industrial commercialization, our subsidiary Aptima Ventures is an incubator for developing companies that can productize our innovations in the private sector. One such spin-off is Sentinel Occupational Safety, a brand new venture-backed enterprise poised to do great things in the occupational health and safety market. Reflexion has more than 50 installations of their hardware and subscriptions to their cloud-based analytics throughout the country in athletics, sports medicine, aging, rehabilitation, and basic science research at institutions like Duke University, the Air Force Academy, and Miami Sports Vision. The team from the University of Chicago have been leaders in their field for a generation, collaborating with labs all across the world. Dr. Nussbaum, as a division director at the NSF and as editor-in-chief for several respected journals, has had a hand in guiding the direction of the entire field, and the team is constantly pushing the boundaries of what is possible in terms of human-machine synergies. We envision a path to technology product that begins with the U.S. Army Medical Research and Development Command and progresses outward into increasingly generalized applications. BOLT BCI will, importantly, be a turnkey product. That means it's not just a knowledge product. It will be physical hardware, professional firmware, and user-friendly software, ready to go out of the box. It will be easy and comfortable to use and fully supported by the development team. Our goal is TRL 6 by Q4 of 2021. At next year's ITSEC, we will show you a fully functional prototype, ready to be tested in real training and operational contexts, productized, and finally deployed. This will likely already be familiar to many of you, but I want to briefly describe how this project will utilize a combination of brain imaging techniques relevant to cognitive and affective constructs of interest. I'll then point to some empirical data supporting the BOLT BCI vision. We'll be using electroencephalography, or EEG, heart rate variability, or HRV, and the galvanic skin response, or GSR. For all of these, we'll be using the Cognionics Quick20R, a wireless dry EEG system that integrates these and other signals into a single data stream. We'll also make use of functional near-infrared spectroscopy, or FNIRS, and eye tracking, which includes pupillometry. Together, these are important measures of cognitive and affective constructs of interest, either via the central nervous system or the peripheral nervous system. Now, I'll point to a few studies using these neurophysiological methodologies. Note that there's a vast literature on the subject. We have compiled and continue to add to an extensive bibliography, so please feel free to contact us for a list of published work on this topic. For now, I'll whet your appetite with a few compelling examples. Rose and colleagues used an EEG-based BCI to train cataract surgery in a simulated environment. On the left, we see behavioral performance on the microsurgery task, with improvements of up to 6% versus controls. On the right, we see increases in efficiency, with BCI training associated with 26% less time to complete the task. Unsworth and colleagues used pupillometry to look for implicit clues about participants' attentional state, while they performed the psychomotor vigilance test. What they found was that on trials with better performance, that is, when participants were paying attention, their pupils noticeably dilated a few hundred milliseconds after stimulus presentation. What's really fascinating is that this technique can be used to probe attention in challenging situations, such as with preverbal children with autism. Finally, this is some unpublished work from Aptima and our colleagues at Auburn University. Take a look at the bottom left. Using motion capture, EEG, and inertial measurement units, Aptima's machine learning classifiers were able to decode various actions being completed by participants. What future capabilities will BOLT BCI enable for USA MRDC? Primarily, BOLT BCI provides the capability to train a foundation of basic visuospatial and motor skills. From medical procedures in the field to combat to piloting an aircraft, tank, or submarine, underlying all complex tasks are a set of visuospatial and motor primitives. BOLT BCI will improve performance in complex tasks by training these fundamental atomic skills. That includes hand-eye coordination, reaction time, peripheral awareness, focus and engagement, contrast sensitivity, dynamic visual acuity, and depth perception. In many cases, however, domain-specific training will already exist. Surgical simulation, flight sims, simulated or augmented reality combat terrains, just to name a few. In these cases, BOLT BCI will serve to prime or potentiate motor spatial learning in specific domains. Thank you all very much for your attention. I'm looking forward to answering your questions along with my colleagues from Reflexion and the University of Chicago. If you have any further questions or would like to get in touch for any reason, please consider the lines of communication open. Beyond that, we'll see you next year.